the criteria is there to consider
Yeah.
it.
So this is very good.
હજુ પણ એવું છે કે સિનિયર સ્કેલ થી સિલેક્શન ગ્રેડમાં જવા માટે 6 વીકની ટ્રેનિંગ ફરજિયાત છે.
હા એ જ હું પૂછું છું આ મેડમ ને. કરેક્ટ. સો ધીસ ઇઝ મેન્ડેટરી.
હા
Yeah.
મેન્ડેટરી.
એટલીસ્ટ સાહેબો બધા શીખે તો બહુ સારું અને છોકરાઓને કામ લાગે અને પોતાનું પ્રોગ્રેસ થાય.
સાચી વાત
એવું
છે.
છે. હા તમે પરીક્ષા કોલેજમાં છો હમણાં?
હા સર, હું કોલેજમાં છું. બેકગ્રાઉન્ડ ચેન્જ કરેલું છે એટલે તમને છે ને કંઈક ડિફરન્ટ લાગી દેખાતું છે.
હા એટલે હું કન્ફ્યુઝ થઈ ગયા કે આ ક્યાં છે, મેડમ ક્યાં છે ને સાહેબ ક્યાં છે.
એટલે અમે બંને છીએ કોલેજમાં, અલગ અલગ
હા
જગ્યા.
ના તમારું મેડમ તમારું તો પેલું કેબિન દેખાય છે મને, પણ આ પરીક્ષાનું બેકગ્રાઉન્ડ બહુ જ
હા વિનયભાઈ છે ને શોખ બધું ચેન્જ કર્યા કરતા હોય છે.
I have changed some background and that's why.
અચ્છા. ના એ ટીમ છે ને અમે વધારે પડતું યુઝ કરતા નથી. અમે લોકો પેલું ગૂગલ છે ને અમારું પોતાનું કોલોબરેટ છે. અમારું બ્લેકબોર્ડ અમે લોકો છે બ્લેકબોર્ડ ટીચિંગ કરીએ છીએ. તો વી હેવ અવર ઓન સોફ્ટવેર. તો એની અંદર
એવું થોડું આગળ રાખે છે કે MS Team યુઝ કરો, તો વી વેન્ટ વિથ ધેટ ઓન્લી.
હા ના અમે મીટિંગમાં યુઝ કર્યું છે, પણ વધારે કમ્ફર્ટેબલ પેલું ગૂગલ મીટ છે, ઝૂમ છે, કોલોબરેટ છે. અમારું પોતાનું સોફ્ટવેર છે તો એ અમને વધારે ફાવે છે. બટ એની આ પણ સારું છે, નો પ્રોબ્લેમ.
પાર્ટિસિપન્ટ જોઈન થઈ ગયા છે ને ઘણા ખાસા બધા.
કેટલા છે પાર્ટિસિપન્ટ અંદાજે બોલો ને?
સર 80 હોય છે. 80.
કોઈ વાંધો નહીં. આપણે તો
રજીસ્ટ્રેશન તો 138 કરાવ્યું હતું. પણ પછી એવું થાય ને એક સાથે ઘણી બધી એમની અપ્રુવલ આવી.
સાહેબોને પકડવા પણ બહુ મુશ્કેલ છે સાહેબો. વેલ કે ભાઈ એ લોકો મોટિવેટ છે અને આ બધું કરે છે, સારું છે.
3 મિનિટ રાહ જોઈ લઈએ.
ના તમે 5 મિનિટ કહો ને, હું તો ફ્રી છું. મારે તો 8 વાગવાના છે. હમણાં મેં નાસ્તો ચા પાણી કરીને બેઠો છે. મેં કીધું હવે તમે ચાલુ કરો એટલે ચાલુ કરીએ. આઈ એમ નોટ ઇન હરી. મારે ફ્રાઈડે હોલિડે છે એટલે મેં આ હોલિડે લીધો તમારી પાસે. એટલે કોલેજ જવાનું નથી. પરીક્ષા મારે એવું પૂછવાનું હતું કે તમે હમણાં બેઝ તમારો મોરબીમાં છે કે ત્યાં પેલા તમે ત્યાં હતા ને ભાવના?
શાંતિલાલ સમાથી ટ્રાન્સફર કર્યા ને.
અચ્છા. એટલે તમને પ્રમોશન
PhD વાઇવા વર્ક થયો ને સર, એના બીજા જ દિવસથી ટ્રાન્સફર આવી ગઈ મારી.
અચ્છા, એ લોકોએ જોયું કે ભાઈ આની જરૂર છે ત્યાં મોરબીમાં.
એટલે મારું અને માયા મેડમ we both were transferred.
માયા મેડમ પણ બીજે ઠેકાણા હતા ત્યાં
જ
હતા. શાંતિલાલ સામા એટલે ભાઈ ત્યાંથી ત્યાં. પણ આ ઉંમરે જવું બહુ ડિફિકલ્ટ છે. પણ આ સરકાર સામે કોણ ભાત ભીડે યાર. જવું જ પડે.
કર્યું છે ક્યાંય મોકલે ને તો થેલા લઈને નીકળી જવાનું સર.
ના એટલે હવે ફેમિલી ડિસ્ટર્બ થઈ જાય ને, છોકરાઓ ભણતા હોય ને આ
બધું બહુ મેનેજ કરવું પડે છે.
એની હવે આ તો સ્પિરિટ રાખવી પડે. ટીચરને આ તકલીફ છે.
એ સ્પિરિટ મને વિનયભાઈએ જ આપી કે મેડમ આવી બધી બહુ ચિંતાઓ નહીં કરવાની.
હા એ છે, માથે ભાર નહીં રાખવાનો. યસ યુ આર રાઈટ. માથે ભાર રાખવાનું નહીં. આપણે જેટલું બને એટલું બધું ઇઝીલી લઈને, કારણ કે જવું તો પડે. હવે
આપણે સ્ટ્રોંગેસ્ટ મોટિવેટર છે મારા અહીંયા. ઇનિશિયલી તો મારી આંખમાં પાણી આવી જતું, પણ નાઉ આઈ એમ ગુડ.
ના પરીક્ષા પણ નોચર બહુ શરૂઆતથી કુલ છે એકદમ.
એકદમ
કુલ. ના વી ઓબ્ઝર્વડ હિમ ફ્રોમ ધ પોલિટેકનિક. બહુ પહેલાથી અમારે લગભગ પરીક્ષા આપણે કયા વર્ષમાં હતા સાથે?
સર we were together in 98-99 સર.
જો કેટલા વર્ષો થઈ ગયા.
આપને સાથે હતા. And
બહુ વર્ષો થઈ ગયા.
still remember we were eating પાણીપુરી at ફતેહગંજ.
શું વાત છે.
આપને વડાપાવ ને જે પાણીપુરી જે મહેફિલો કરી હતી, આપને EDC પાર્ટ ટાઈમ ચાલુ થાય.
આમાં ખાવાનું ખરેખર માયા મેડમ બોલે છે ને કે વીક થઈ ગયું, પણ આ અમે ખાવામાં આઈ એમ રિયલી ફૂડી. બહુ ખાવાનો શોખીન છો.
આઈ નો સર. તમે મને સરસ નાસ્તો કરાવ્યો હતો.
એ તમને યાદ છે?
હા, બધું જ યાદ છે સર. પણ જેમ જેમ સર ઉંમરની સાથે મેચ્યોરિટી આવતી જાય ને.
કરેક્ટ. ના હવે આની શું છે, ઘણી બધી તકલીફો ઉંમરના સાથે છે. આઈ એમ ક્રોસિંગ 60. તો હવે એ પ્રમાણે થોડા પ્રિકોશન લેવા પડે ને હવે.
સાચી વાત છે.
બસ પણ અમારે પેલી પોલિટેકનિકમાં અમારા ભાવસર સાહેબ નહીં, ભાવસર સાહેબ તો ઓછા, પેલા વીએસ શાહ સાહેબ, વિનુભાઈ અને નવીન શાહ, એ બે જણા બહુ ઓર્ગેનાઇઝ, એ લોકો અમને ખાતા શીખવાડ્યું કે ખાવાનું કોને કહેવાય છે. અમે એને સારી રીતે યાદ કરીએ છીએ કે ભાઈ આ ભાઈ ત્યાં અમે ખાલી પાણીપુરી શું બધા દુનિયા બહુ બધી વેરાયટી ખાધી ત્યાં. માટલા ઊંધિયું લઈને શું નથી ખાધું એ તો પૂછો ત્યાં. અને ઇવન અમારે પેલા એ વખતે વાઇસ ચાન્સેલર સાહેબને પણ ઇન્વાઇટ કરેલા, અમે 2-3 વખત કાને સાહેબને બોલાયેલા, આપણે આરસી પટેલ સાહેબને બોલાયેલા. એટલે પીપલ વેર વેરી ફ્રેન્ડલી, બહુ સારું ફેમિલી એન્વાયરમેન્ટ હતું ત્યાં, બહુ સારું હતું.
Sir, Dr. Nittal Nirmal has also joined. If you want to
નિર્મલ મેડમ તો મને બર્થડે વિશ તો ભૂલતી જ નથી. ક્યાં છે? દેખાતી નથી મેડમ, દેખાઓ, તમારા દર્શન આપો. હા, તમે એક વાત મેં જોઈ કે તમે કોઈ દિવસ મિસ કરી જ નથી. મને બર્થડે વિશ એક રેગ્યુલરલી તમારી મળી છે અને હું હંમેશા તમને રિસ્પોન્ડ કરવામાં લેટ જ પડે છે. વેરી સોરી. હા મેડમ, ક્યાં છો તમે આજકાલ?
સર, હું અહીંયા શાંતિલાલ શામાં જ છું અહીંયા.
અચ્છા, ચલો, વેરી ગુડ, વેરી ગુડ. અને તમારી ફેમિલી, મધર, ફાધર બધા ઓલરાઈટ?
ઓલરાઈટ સર.
હા, ચલો, મારા નમસ્કાર કહેજો એમને, કારણ કે તમારી મધર તો મને યાદ કરતા હતા, તમે મને ઇન્ટ્રોડ્યુસ કરાયેલા એક વખત અને કીધેલું પણ ખરું. તમારી ટીચર જ છે ને તમારી મધર? હા, એ મને યાદ છે. યસ. અને
એમના મમ્મી પણ એમની જેમ એકદમ કુલ છે સર,
નિર્મલ મેડમ મારી જોડે પેલા માસ્ટર્સમાં હતા ને ત્યારે હું અને કુરેશી સાહેબ હતા, બંને મારા પેલા ભાણિયા. ત્યારથી છે આવે એટલે પેલું નમસ્કાર કરવાનો, પગે પડવાનો અને શું નથી કર્યા મેડમ. આઈ રિમેમ્બર મેડમ. હા, ખરેખર તમારા જેવા બહુ ઓછા સ્ટુડન્ટ મળે છે. હવે સ્ટુડન્ટ શું, હવે તો કલીગ થઈ ગયા, આપણે સાથે ટીચર જ છીએ, પણ દેટ વોઝ અ વેરી ગુડ ટાઈમ. વી એન્જોયડ યોર કંપની. સારું કહેવાય. ભટ્ટ સાહેબ મજામાં છે? ભટ્ટ સાહેબ બહુ બધા પીએચડી કરાયા. અચ્છા, વેરી ગુડ. મારા યાદ આપજો ને ભટ્ટ સાહેબને. મને એમણે બહુ જગ્યાએ એમણે રાખ્યા, મને તમારી કમિટીમાં ને એક્સપર્ટમાં બહુ બધી મેં પીએચડી થીસીસ એમની જોઈ. પણ હવે સાહેબની પાસે કેટલા વિદ્યાર્થીઓ હોય નોર્મલી તમારે ત્યાં એક ટીચર પાસે?
આઈ થિંક 6 જેટલા હોય છે.
અચ્છા. હવે તમે આગળ વધો, એક બે સ્ટુડન્ટ લો હવે તમે, હે ને? જયારે તમે એલિજિબલ થઈ જાવ એટલે તરત જ લો. મેં પેલા સિરાજ સાહેબને પણ કીધું કે ભાઈ એકાદ લો. અને આ પ્રવૃત્તિ રાખવાથી શું છે કે તમારું પણ ડેવલપમેન્ટ થાય અને સ્ટુડન્ટનું પણ થાય, અને ફ્યુચરમાં આપણે એક સારું કામ કરીએ એઝ અ ટીચર, જે આપણા માટે આપણે બંધાયેલા છીએ. મોરલ ડ્યુટી કહેવાય ને.
Actually, Siraj has also one lecture in this FDP, sir.
હા, મેં જોયું. મારી બેબી છે ને કરિશ્મા, એને કીધું કે સિરાજ સર ને લેક્ચર लिया. मैंने चलो बहुत अच्छा है.
And he has also told that I have a proposal for PhD in FMS. If anyone wants to pursue PhD under him,
very good.
He can definitely join.
ના, હવે તમે પણ થોડો આમ. Please carry on.
I'm taking this opportunity, Qureshi Saib, to introduce Dr. Qureshi sir. I request Professor Amit Panchal, who is an assistant professor in production engineering department at Eli College, Morbi, to introduce Dr. Qureshi sir to the participants, to the audience. I request you, Miss, please.
Thank you, madam. Thank you for giving this opportunity. Very good morning to everyone present in this session, day 5, first session. And today's expert is Dr. Aman Qureshi sir. Giving brief note about Qureshi sir. He is currently working as a associate professor in industrial engineering department of College of Engineering, King Khalid University since 2013. His research interest is in flexible manufacturing system, optimization, TQM, welding, non-traditional machining, logistics and supply chain management, e-learning, sustainability, and many more. Dr. Qureshi has published more than 150 research papers in various reputed journals. His Google citation is around 3,400 plus, and 27 of H index and 48 of I index to his name. Uh, he has done his PhD from IIT Roorkee in 2008. He has worked in Asian Brown Bori Limited for 8 years and worked in Mechanical Engineering Department at MS University of Baroda for more than 30 years. He has guided 9 PhD students and two PhD going. Uh, he has done few research project consultancy projects like e-learning, CSF, and various in Saudi universities, and provided consultancy for lean manufacturing, time and motion study, value mapping study of Indian industry. He has been awarded as Best Employee Award for at King Khalid University in 2016-17 and Best PhD Thesis Award at 3rd PIMB International Conference 2011. With this brief, I would like to hand over the session to Dr. Qureshi sir. Over to you, sir.
थैंक यू वेरी मच. हमें नॉट ब्रीफ वेरी डिटेल बायोडाटा हमें बताई देता. थैंक यू वेरी मच. ओके, सो आई शेयर नाउ जस्ट मने को के
जी सर. Yes sir.
Hello. Sir, namaste.
Is it, can you see my screen देखाय छे?
हाँ, क्लासेस लेती है, नडीते थे क्लासेस ಎಲ್ಲ.
नहीं देखाते.
क्लासेस ಎಲ್ಲ. हाँ.
Now you see.
हाँ.
It's okay now?
Same rate.
Yes. Now it is visible.
But ಅಲ್ಲಿ ಏನು ಆಗ್ತಾನೆ ಇಲ್ಲ ಕನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಎಲ್ಲ.
Okay. See, good morning everybody again. Today's topic is IoT enabled industry 4.0. But what I'm planning, because this last day of this STTP, so maybe you have gone through this IoT enabled industry or many areas of IoT for industry 4.0. So I'll be trying to change some of the area so that you will be able to learn some methodology. So I have selected this RFID, and I'll be briefing out RFID, and then we'll try to solve some research paper. So that you will be accustomed with solving the research paper or how to write research paper. So maybe you are interested. So we take two methodologies if time permit. Otherwise, I begin with the analytic hierarchy process. As such, there are many multi-criteria decision-making processes like TOPSY, select ray, then gray. So many things, so many are available. Even this best and worst method. So out of this, we will try to see the very easiest and where you can write a research paper. So that I will try to cover it. So to begin this, sir has very nicely briefed my biodata and my career path to you. I have been working in many areas. Basically, I started my PhD in logistics. And logistics supply chain is my core area. Then people joined me as a research scholar, and then my area started to be growing in various multidisciplinary as well as mechanical area and industrial areas. So still my two students, they are working on composites. One is working on chicken feather, and another is working, but problem is the composite manufacturing is difficult for him. So that is still we are trying to find out nanomaterials which is suitable, and we can make it worth to some research area. So whenever you are working, at least it should be we should be able to contribute something in the research area. Then it is at least satisfying for us. So to begin with this, this will be my plan to cover it. I will try to introduce IoT then the roadmap to Industry 4.0. This I will hurriedly do it so that I don't waste time. You are already maybe now at the end of this STTP, you have become accustomed or maybe somewhat expert in this area. Then I introduce you to RFID. Then we talk about various RFID system, then various RFID components, then the role of IoT in production management. As such, it is applicable to many areas, but we will try to stick to some areas so that we can speak more. And then some conclusion and reference that we'll try to do it. Now, as you know, this IoT, Internet of Things, anything which is a main or a device or a object or a computer which is involving in this data transfer, we call it a Internet of Things. So you see this now we have been using Internet of Things in our household application. Say you want to switch on the fan. So by clapping or by speaking to Google, you can start the fan, you can switch off the fan, you can link your tube lights, household lights. Many things you can do it very easily. We are using Internet of Things. So Internet of Things is doing a lot of very good area, a very good performance in many areas. Nowadays, we find a very good application of IoT in hospitals, in hospitals management, in inventory management. So in my presentation, you will see where this IoT will be helpful in some commercial area, some non-commercial area or industry area. So as you are aware, there are different industry regulations and through which we now try to name it as 1.0, 2.0, 3.0, 4.0. So these are the different jargons which we name so that we can classify our industrial revolution into some specific era. So that we can remember that what was the important points, important things in those era. So as you know that we began with mass production, then slowly we go for automation. Then slowly we introduce, call it as a robots or AGV, automated guided vehicles in our industries. And then we switch over to Wi-Fi. So Wi-Fi has changed so many things in our industry, and we are now moving, or almost we are in that era of smart factory. So this mobile applications and computer application using Wi-Fi has enabled us to do many work without we can switch on we can switch on our industry or machines or many things remotely. So this is the main advantage which has come to us. So as you know, when we switch on automation or automation using different devices, it is very useful for us to have the benefits. These are the some backgrounds of IoT or industry, you can call it, because in industry you use IoT. So cyber security, cloud computing, mobile technology, machine to machine. We are basically interested in machine to machine integration, how we can connect them and how we, just like FMS, flexible manufacturing system. But here we'll be using IoT to get the data, and those data what we have will be using it for future purpose. So 3D printing, advanced robotics, big data analytics, Internet of Things, RFID. So cognitive computing, cyber security, what is the very important pillars of Industry 4. So if you see here, what today I'm going to go into detail is RFID, so radio frequency identification. So this particular thing is not new. It has been in process, but because of this IoT and because of this integration with industry 4.0, we'll be utilizing RFID more productively, and it will be helping in many areas to have inventory management, production management, work in progress management. So many things are there, and even for customer satisfaction, customer delivery, this RFID is playing a big role in that. So in our intelligent factories, intelligent machines or smart materials, we need this what you call pillars, and we require the Internet of Things for driving towards intelligent production system. That is 4.0 scenario. So in that we use various technology pillars, and today we are going to see this RFID as one of the things. These are some of the main elements of Industry 4.0, where we have a cyber physical system. We must have the hardware and we must have the network, so that we can support or we can provide the base for exchanging the data. What is we call it is a EDI, electronic data interchange. So you must be using, or rather we are using this in production in many areas, like in mall. We use barcode. The moment we swipe the we use the barcode sweeping, and the moment you do this process, immediately the signal goes or the data transfer through EDI, and we'll be able to track how many components are sold, or how many products are being sold, how many are in inventory, or what is the amount that has been received, something like that. So you do many things using a simply barcode. So now when the RFID has come, it is more easy. You can make delivery, you can do tracking, tracing, you can make your customer happy, and you can imbibe them to be a loyal customer. So this is a very good thing. Because of RFID, we can do so many good things for customer satisfaction. So IoT is part of that, which help us for smartphone or sensor to communicate with a human being intelligently. So this IoT is required nowadays, and it has been changing our world, not only physical world of our day-to-day life, but also the production. Then Internet of Services. So it provides interfacing to all connected devices by simplifying the process. So under iOS, you can have many commercial services which will be helpful for us to maintain our day-to-day business smartly, intelligently, and more effectively. And another one is a smart factory. So this Industry 4.0 will have this many components or elements, so that it functions very nicely, and we get the results what we are heading for. So IoT and integration with human, with machines, and for integrated process is a crux in this Industry 4.0. Now, when you see this IoT CPS, cyber physical system, and when you see machine M2M communication, and autonomous robots, then cyber security, UAVs, cloud storage system, additive manufacturing, augmented realities, and big data computation, this will help us to carry out so many analysis, and so many things can be done so easily. Because when you work on IoT, there is always a danger that if Wi-Fi or your security is when somebody or hackers or somebody who is trying to hack your system, then this will create a problem. This will make a lot of problem, and the system may go down, or maybe the system is down for a long time, and unless you create idle hours for men and machines. So you need cyber security, and for exchanging data very nicely, we must use a cloud storage, because now data are abundant, and you can't store with simple gadgets or simple computers or servers. You must take a help of cloud, and you can store this data into the cloud, and whenever it is required, you can interface it. So this is very important. And then now we have autonomous robots, and now the robots are also integrating with humans. So earlier robots were not so very intelligent, but nowadays we have intelligent robots, and they take decisions also. So there were in past many accidents which were reported by robots, and workers or humans, they were not together in the same area. Many times it has gone to that level. But now the robots and the humans both are sharing the same work area, and they are intelligent. You see this also in the area of additive manufacturing, and the process of manufacturing a complex or complicated product or semi-products have been done very nicely, easily using additive manufacturing or 3D printing, and we are able to realize the things whatever we want it in the production areas. And the big data computation has helped us a lot to retrieve the data whenever it is needed, and to formulate many processing or analyzing data easily using this big data analysis or big data computations. Now, if you talk about the RFID, it is a system. So using some kind of RFID tags, then reader, and then connecting with the servers, so that we can identify in nearby area what is the component which is available, what are the processes which are going on. So it provides a link between process flow data with physical asset data. So IoT Assist accumulate a lot of data through RFID tags, readers, and sensors. And this will help us to provide transparency, efficiency of production management, because data are very much important. In supply chain management, if you have a right data and you share the data with your upbound or downside or upside supply chain, then this transparency will definitely help to restrict a bullwhip effect. And you will be dealing with a lot of advantages, like minimizing the inventory, keeping track on the flow analysis, and you will be taking and tracing the components, making it to the right delivery time and right destination with good quality, something like that. So this RFID system is very, very helpful nowadays in our industry 4.0. Many people have been using this RFID earlier also. There was a very famous advertisement earlier where the person was driving on a highway, and suddenly he gets a call, and using this RFID system, he transfers his components to some other destination. So this kind of RFID system is very, very important for a manufacturer, for a any executives or a managers working in this area, to track and trace the component assembly product. So this will helpful to customer, or this will helpful to production manager to commit the time, delivery dates. So many things is depending upon this. So this RFID plays a very, very important role. Now, RFID technology is based on the radio technology that uses the radio waves, and to identify the tags attached to an object, and thus identify the object. So whether in that vicinity, in this area, maybe there may be many RFID tags on different components. So this radio technology, or rather the waves coming out from this RFID tags, can be read from the reader, and RFID reader will be able to give you the inventory exactly in real time. So this is a very big boost to make a decision, because you require a very dynamic decision making to commit to your customer, or keep a job loading on the machines, not to keep it idle, maybe main machines. So many things can be managed very easily. Another area where this RFID technology is largely used is in logistics. So in logistics application, it is very good. You see that many automobile manufacturers, they do not produce a complete component. They give it for outsourcing. So this outsourcing is managed very nicely using RFID. And because of this, there is a minimum transportation. This is the beauty using RFID. So in General Motors in Baroda, in Gujarat, they have Maruti Udyog nearby, and they are manufacturing the doors. So as soon as this assembly is about to complete, the doors are managed from third PL, 3PL we call it, third party logistics. And using this RFID technology, these doors are taken into the assembly shops, and they are mounted to the automobiles in a real time. So this not only solve the problem of inventory, but also solve avoid the damaging of the doors. So it's very delicate. So sometimes these kind of things are not only helping to maintain or boost quality, but also maintain a smooth flow so that there is no unnecessary storing of the components in inventory and then issuing, delivering. So many transportation can be minimized. And you see, whenever you transport anything or handle anything, it does not add value to it, but it always add to the cost. So our, as a production engineer or a manufacturing engineer, our game, or maybe the objective of the main work is supposed to be not to transport unnecessarily, not to handle unnecessarily, so that it does not add cost to any process. So this is how we can manage. Now this is some timeline what I am trying to say, that this RFID is not new, but it has come to limelight because of IoT, because when one area is working very nicely, the another area is also grow. Walmart has been using this RFID for maintaining the inventory. So as soon as the inventory or the customer takes out or purchases something, at counter the cashier sweep the barcode, and immediately the Walmart signal or through EDI, it goes to the particular manufacturer. Say, for example, Dell has given some computers on the shelf of Walmart. So maintaining inventory of Walmart shelf is not the baby of Walmart, but it is the duty of particular manufacturer. Say in this example, Dell. So as soon as they come to know that now that inventory has gone below the safety level, immediately there is a what you call invoice generated automatically, and there will be a container or whatever logistics equipments or logistic machines or they have in their day-to-day working, they adopt and transfer those products, what we call it a SKU, stock keeping unit. So those SKUs are replaced, and there will not be any bulking of customer. Customer will not be maybe if he doesn't find the required components of product in the shelf, he will go to another say mall. So these kind of things can be avoided very easily in real time, and we can maintain it. So this has been what I'm trying to say, that this has been in the our day-to-day life. But why this has not been used in India so before so many years, and why we have been deprived of this facility? So important thing is it's a cost per take, because this the RFID tag is very costly. And when you have this costly tag, it will add this extra cost burden to customer, and customer will not be ready to pay. Customer needs quality, of course he will be ready to pay, but some extra service he may not like to pay. So cost per tag is very expensive in the earlier days. Now it is dropping down. Now you see maybe by 2025 the price drop we will be able to see this. So now using this timeline, we can see that in near future we will have RFID in most of the products. maybe it is a commercial or maybe it is a non-commercial product, and we will be happy having the benefits of RFID. This is the RFID system, in that where we have a computer database. There is a RFID tag on the product. Using antenna, these signals are captured, and it is taken by the RFID reader. And once this RFID reader reads it, it supplies the data to EDI, and we are able to manage the inventory or whatever process, maybe invoicing. It will invoke invoicing, or it will send a signal for a production manager to start the machine. So like that. So many things can be done when you get this kind of data, because now data is very important in industry 4.0. So unless you have data, you can't take a correct decision. So this will be helpful in many ways. So dynamic decision is very easily can be done or can be taken, and this will help us to carry out the process. Now, if you try to see this main crux of this, how this system works, we have different types of RFID. One is the what you call active, and another is passive. So if you see here the passive RFID, the passive RFID takes only give off a signal when an antenna distribute a radio signal to us. So it is, the name itself suggests that it is a passive, so it will not active by itself. And in active, you have a lot of signals. Since active RFID tags are constantly generating a radio signal, they need to have a power source. So some additional cost will be there, because we have to create a power in that. And here we manage it through some other device, and whenever we require, then only we activate it. So comparison you see over here, that the cost is definitely high in this active type RFID. And see, the range is also more in case of active. So we can take and trace from very long distance, 350 feet, or nowadays 25 meter or more. That is where it has been coming out. So this range is going to increase in future also. So people will be able to track and trace very easily in the future. This is the industry area where nowadays it has gone to too many areas. See, earlier it was limited to taking tracing in the inventory in industry like manufacturing, distribution, and wholesales. But now it has gone to workshop level, process level, and that is very important for maintaining and cutting down the downtime. So you see automobile industry, maybe you health industry, or maybe you see in IT. So many things we can use this active and passive RFID. So we have a tag basically. This tags normally connect to the antennas, and then this goes to readers, and then it connect to computer database. So these are the four basic components, and you can understand very easily. And some frequency, low frequency, high frequency, or ultra high frequency tags are available in the market, which we can utilize very easily. Now there are some low frequency tags has a range, and based on that we can select whether you want it a low frequency or high frequency tags. So it can read a span of a few inches, lowest data transfer rate, then store a small amount of data. So because storing a data is very important. See, we started with maybe I don't remember 1.2 MB floppy disk, then we go to 1.44, then we go to CD, and then USB has come. I don't know what not has the new things are coming in IT. So this whatever amount of data we are storing now will be not suffice and will not be sufficient for a future requirement. So we will be going for further research, and we will be using different types of tags to fulfill our requirement. So See here, this has been used in many part of our country. In India, they try to control the nuisance of buffaloes or animals like cow or something like that. So they try to keep this RFID tag and they try to puncture the ear and they put it over there so that they can recognize the movement of the cow or buffalo or something like that to avoid accidents, unnecessary accidents, because they are many times found on the highways, roads, and jamming the roads or making accidents and causing problem to human beings. So we can use this LF application in animal tracking, access control, car key fob, asset tracking. So still we have been using, in healthcare also we have been using this. Then we have high frequency. So this primary frequency range goes to 13.56 megahertz, and read range is very limited, 30 centimeter. The capability of reading multiple text simultaneously. So this is the advantage. It can read more than one text and can store up to 4K of data. So some limits have been increased over here. So this system has been used in many libraries. The moment person use this book for delivery officially, they will detach this RFID text and he can pass on very easily. The moment person try to or student try to avoid this delivery gates or something like that, they try to take it unofficially. So it will give a alarming signals and people will able to know. So this is also useful in many souk, what we call is the mall. In many mall, we are using this. So all garments, they are attached with this kind of things. So moment somebody try to sneak out of it, it will give a alarm. So it can be used for personal ID cards also for your payroll. The moment worker enters, nowadays there is a thumb impression. You just put your thumb and your payroll absenteeism or presence can be counted very easily. But this is one of the things which have been used in many other industry, and nowadays people are still using this personal ID cards. Some gates are opened using your ID card. Some gates are given permission through this. So you can keep privacy, and people will be only authorized. Person can only enter into some specific area. So these kind of things are still there. Then airline baggage is very easy to track and trace. And there is also use in credit cards. This is ultra high. So this is a very good one, good range, 25 meters and high data transmission rate and a very wide variety of text size. And we can use it in supply chain, manufacturing, pharmaceuticals and electronics, tolling. So this will be helpful in many areas and very effectively we can use it. So as we have seen earlier, there is a active and passive. So this is what it is talking about: vehicle tracking, auto manufacturing, and construction. So this is a UHP active text battery operator. Now you see this RFID application in production. So here you can manage your inventory. Sorry. Object location detection, RFID using MES, manufacturing execution system, planning, scheduling, material flow monitoring, quality assurance system. Now the application of this is not limited to this only. These are the main applications which I'm trying to give you. But you can explore in many areas this RFID and you can use it very effectively. This is one of the applications which I told in the beginning of my presentation, that RFID is nowadays useful in HMO for health maintenance organization. Nowadays these doctors or nurses, they can see their inventory in real time, whether it is available in the store or it is available in their triage. So this is very, very important because the emergency in the hospital has to be managed in real time. So as soon as the doctor needs some item, he orders. or he sees from his mobile or from his iPad or something like that, and he can make a request, and that request can connect to the when you have this data interchange, then we can very easily connect to cloud, and cloud can interchange the data very easily, or it can share with the IoT system, or it can share with some kind of server. RFID reader will read, and it will be giving you the real time the status of the available items. So see here, there are different signals which are shown over here. Items equipped with RFID tags. So unless you have RFID tag, it will not be caught by this RFID reader. So depending upon the requirement, the person will be trying to take the note of availability, and he or she, the doctor, can prescribe the things, and it can be made available to the patient in real time. So this is a very good application of RFID in maintaining health. Then you can still use it for warehouse management, for bigger data or bigger important things. Nowadays, you see in Corona, people don't have, in first or second wave, people have a very less time to manage the inventory. There was a oxygen shortage, and people were running from hand to mouth to manage it. So if this kind of system is adopted, people will be knowing the exact thing in real time. So this is very good application in this area. Now, as soon as you have RFID tag, which is shown over here, like a label, RFID tag has a barcode and has a lot of data imbibed in that. And the moment you have this RFID reader, it is taken the data from the server through internet, and it can exchange the data in a real time. So this is how we can see in a nutshell, or as a very layman technique, we can see how it works. So if we see the different types of RFID tags, it will be serving a different purpose, and the cost will also increase. The amount of data stored by this will be very easily change from type of RFID tags you are using. See, this is a key tag. Sometimes you can use it for animal. Then there is a different types of ear tags here. Then metal tags, we can stick it to some kind of object, and you can track and trace the object. These are the button tag. These are the glass tube tags. So many varieties of tags are available, and you can use this in different industry. So which kind of tag will be more effective to a particular application? That is a question of research. So people can make a very good model, decision-making model for various industries, so that people will not waste time, and they will be able to select which type of tag will be economical, which will be transferring more data, which will be real time, spares less time in transferring this, and distance controlled, and what will be the amount of power required. So many factors. So this will be what we call it is a critical success factor. So this CSF can be prioritized. We can find out the weightage, and we can do decision making paper, research paper very easily. So whenever there is a decision making involved, we can very easily apply analytic hierarchy process. So I will try to give you some idea after I finish this basic introduction. Now here you see RFID tags has the cost criteria, because why India is not been any dominant in using RFID tags is because of the cost. We don't want to burden the customer. The customer is not able to, or rather will not be willing to pay this additional cost. So as soon as the cost goes down, people will see facility also, and the people will be ready slowly and steadily agree to use this RFID tags. So there will be, or maybe because of some laws or some environmental laws, because the people are throwing after use and not using a proper methodology to dispose the electronic gadgets. So there may be in future some guidelines from government, and people will be using to use this RFID tags compulsorily. So maybe in future, we don't know, it will be mandatory to stick to computer or smartphone, so that after the use it has to be maybe properly disposed to Mother Earth, or maybe you refurbish or recycle or something like that. Recycling is possible in many electronics components. So disassembly, something like that can be think in that. So there is a reverse supply chain. People are already working, and it's a very rich area, and people have tried to find out so many solutions to how electronic items after use can be removed very easily without harming the environment. So that is another area. So this is RFID tag low cost. So on the left hand side, you see the standard power source, storage, circuitry, reading distance, price, physical, resistance to use. So people can use different types of RFID, whether to use low cost or RFID high cost. So sometimes for different application, this will be a question for a production manager, which kind of RFID tags he use. So this is another area, or a small maybe Scopus type paper you can write based on this. These are some of the criteria where based on this criteria you look for some specific application where you can use it, whether to go for RFID or whether low cost or RFID with high cost. So it's just like a break-even point. If you select this, this will be effective. If you select this, it will be more effective. So, but depending upon your application, because see, there are limitations up to 3 meter, up to 10 centimeter, about 10 centimeter. Then storage, how much data you want to store in that. So how much electronic software and hardware are required. So everything depends upon this. And then basically the cost, 0.05 euro or several euro, something like that. So this is how we can still write one paper for different industries. Say, for example, you are working for a packaging industry. So which RFID tag will be useful for packaging industry? Because you can track and trace the package item. Unnecessary, you cannot afford to unpack the package component. So to keep it things in order, to keep the inventory intact, you need this RFID tag so that you can maintain very easily. In Saudi, there are many varieties of tissue paper they are using instead of handkerchief. So I have been there in factories of this tissue manufacturing to give the dissertation or some kind of training to my students, project to my students. So there I have seen the variety of tissue papers, what they are making. So there are different varieties. There are rolls in small tissues or big tissue, large tissue, different types of paper they are using, and different types of what you call the packaging they are using, and so many varieties. So it is very difficult to track and trace the inventory, and the store is full of this. Maybe you don't get immediately the requirement, so there should be a inventory which will be useful in future. So inventory turnover is a different aspect, but since this is a low cost product and requires a huge volume, even the raw material for this tissue manufacturing stores a lot of space. So that is to also to be maintained. So in process also maintaining, cutting, then there is a process of roll which has to be cut into proper size. Then there is a process combining two papers so that it becomes thick. And then there is a process of packaging and numbering, and you use it for packaging manually or something like that, automatic machines. So this kind of RFID tags will be helpful for them to maintain. So what kind of RFID tags will be helpful for a tissue manufacturing? You can write a very good scopus paper for this. And this is one of the idea what I'm just trying to give you. You can still explore. Once you go through this, you will be able to find out. Then another is frequency. What is the best frequency which is used in RFID? So this is I have taken from Google, and this has been done by some case studies, and they found that the high frequency 13.56 megahertz has been used much more in use, and the list is the chipless 2 hertz to 100 gigahertz. So these are the normal range. So which range will be most used? On this frequency band also you can select the type of RFID which will be useful for a particular industry. So there are so many factors now, and when you involve these so many factors, the decision making becomes a complex. So production manager may be in dilemma what to select. So then we can prepare a very good HP based model to help this kind of production manager. So this is a good thing you can understand very easily. This is a process by which we can read the tag, and you need some energy for RFID tag to be, as we told, is if it is active, then you require energy for this, and the RFID reader will catch the signal and will give you the data. And this data will be useful for decision making. So this is how it works. There are various readers, handheld readers, so that it will be very easy for a person to get the things around, and he can take very easily this data into consideration. This is something which we already talk about, that long range RFID referred as RAIN RFID. This is a practical application for long range and low range format. So again, this will be helpful for your decision making. These are the highlighted words are for your CSF, critical success factor, whether or criteria. So there is a 15 meter, 1.2 meter, then smartphone users, low tech recognition, consumer trading. So there are some application is also given. Their length or vicinity area is also given in the meters, and where we can use it. So this will be helpful in decision making. Now in the future, the smart factory will have this many things around this smart factory. You see the smart machine, smart products, smart logistics, everything is named as a smart. So where we are using Wi-Fi or IoT, Internet of Things, we change these names, and the new jargon becomes as a smart. Everything becomes smart. So, but definitely by involving IoT, we'll be trying to use these machines or services in a more fruitful way. So use has become more and more, and we have been getting more production efficiency in the production room. So like smart cities, we have now smart factories, which will definitely help our future GDP, and we can grow at a very good pace and compete with the global market. This is how the IoT has evolved from generation 1 to generation 2, generation 3. So it has gone very far, and we have been using RFID sensors, and now we use interchange or interact with cloud information centric networking. This is the RFID for industry 4.0, and this is RFID what we have been using earlier. So left side, if you see here, remote monitoring, multi-sensing, extra computing, fine power management, localization. But here now, if you see that because of IoT, there will be much more use in this. So we have to use RFID in the the coming era in Industry 4.0, where it will be helpful in many areas to support our network or to find out in real time, and we use it substitution to the wireless sensor or something like that. So we can identify and we can capture the data smart way very easily and very effectively. This is how the data has been sensed and it goes for decision making. So our main area is decision making. Using this, we can make decision making, and this decision made by production manager or any executives will be fruitful. So this is what is required is very important. Now, many areas as we talk may be useful in retail, maybe in logistics, in manufacturing. So those who are in this area, somebody working in logistics, supply chain management, can just try to find out what kind of RFID or system or tech will be helpful and how it will benefit the production efficiency of or the logistics management easily and effectively. So this will be a good research objective for a supply chain management area. Now here, RFID technology, what we have been using in logistic area or in what we call hospital management or in production management is depending upon your requirement. What exactly you want it from RFID. If you are simply want the quantity, so you require a different types of RFID tags, and the cost will be very low. So maybe around $1,000 or something like that, you can get a reader, RFID reader, and this RFID tags will be around 50 cents or something. And if it goes down to minimum, we can use it for future for managing inventory and so many things. So in a nutshell, this is a very useful RFID for Industry 4.0. And this will definitely help us to maintain the data. And in future, the data will play a major role in sales forecasting, in production management, in customer management, and customer satisfaction. So many things we can do it very easily using this RFID. So this, I just want to extend this to a research so that you will be able to solve some problems. So I conclude over here the basic information regarding RFID, and then using this base, we try to solve one research problem so that we can see how best we can use it this. Okay, so I switch over to some research papers and try to see what we can do it here. See, I have downloaded some 3 research paper from Google Scholars yesterday night, and I will be trying to explain that what you can write using this AHP. So there are 2 examples here. One is AHP and fuzzy AHP. So of course this is a conference paper, but you can extend this and you can build a very nice paper for maybe a Scopus or some impact journal paper. So this is basically for selecting RFID system for glass industry. So you can select different industry, maybe packaging industry, maybe production or manufacturing industry, maybe somewhat textile or something like that. Where there is a good scope, you can use this industry, and then you can very easily find out what kind of RFID system has to be adopted. So I just go through these factors which are very important for this, and then we'll discuss how the methodology will work. So now here is a first methodology. This I don't want to discuss because I want to discuss first the AHP, but I pick up some of the what we call hierarchy, because this AHP is analytic hierarchy process. So it's very important that you decompose your problem into some kind of hierarchy. Then it will be very easy to solve. So there are 2 approaches in this. One is analytic hierarchy process. Another is analytic network process. So normally we decompose the problem into this hierarchy. So this is the beginning of the first step of any problem. So what is our goal or objective? So that objective has to be on the top. So selection of the best RFID system. Our aim is to find out a very good or potential RFID system out of this alternative system X, Y, and Z. So you must have some alternative. Without this alternatives, it will your problem will look shallow. Of course, people can do the priority or weightage of this sub criteria or the criteria. But if you have this kind of alternative, then it will be worth more benefiting to production manager or people who are at the higher level who makes a decision. So this is my first level, this is my second level, this is my third level, this is my fourth level. So we can call it this is a goal, this is the main criteria, this is the sub criteria, and this becomes my alternatives. So based on what criteria I am trying to find out RFID system. So this is my criteria, investment factors. Okay. Then I have system characteristics and then vendor criteria. Like that you can Google out and find out some more criteria so that your paper will become more comprehensive. Instead of taking these three, you can go up to 8, 7, 9, something like that. Some meaningful criteria you can dig it out from literature review and then try to build up this sub criteria as well. And once you find out this sub criteria, you can compare the available system which is best suiting to this. Many times there can be 5, 6, 7 or some system, but you can sort them out to maybe 2 or 3 so that your calculation becomes less. So here we are interested to make a less complicated calculation so that we can easily arrive to some decision. Now here if you see that investment factor, this author has taken A1, A2, and this A1, A2 is here, total cost, implementation cost. So when you buy any RFID system, you require this total cost, implementation cost. Now you can add some more training costs. You may require to train your workers or people so that they use it very effectively. Because some new system comes to the maybe in production system or maybe some other area, we need some training. So you can adopt this, or maybe you can have maintenance cost or something like that. You can dig it out from literature review. So this A1, A2 is can be expanded to A3, A4 or A1, A2. It's okay, no problem. Then B1, B2, this is system. What system you are going to work and in what you are going to interface. System reliability and performance. So what is the speed, what meeting the requirement of the glass industry. So this will be unique. If you go for say packaging or textile, then you have to think about this. So this will change from here. Then integrating with ERP. Because normally the people who are using this sophisticated system or something like that, they used to have ERP. So when you have enterprise resource planning system or some kind of MRP or something like that, you can very easily imbibe this or connect and you can integrate very easily. Is in filtering data. So many data will be there. What will be filtering this data? How you can find out the required data and how you can filter the unnecessary data. So this B1, B2, B3, B4 are here. And the B5 is over here. That is a flexibility. So it provides you flexibility in the process. And this will be helpful for you. So you can use this RFID system from one place to another place, one unit to another unit, one process to another process like this. And then vendor criteria. So vendor reputation and after sale service. So this will help some value addition in giving a customer satisfaction. People will relying on some particular company and they will be able to use this C1, C2 for their enhancing their aesthetic or maybe their loyalty or branding, something. So many things can be connected over here for vendor criteria. So this will also reduce time as well because of this. So you can use this criteria and then you select about the system. So you need to find out what is the available system. So X, Y, Z, these three systems are available, and you have to do some review of literature, go to the market, or who are the, there are so many things available on net. You can find out very easily different configuration of the system, and then you can very easily decide over this. Now the important thing is in ASP we have to compare the process start with hierarchy, and second process is how to compare these three criteria, main criteria, or we can call it as a this is a weightage. What is the importance of these three criteria? So using somebody experts, because AHP uses a human judgment from decision makers. So we have to invite some team, or maybe single or group decision making has to be done, and some expert has to be called, or say we have to sought help from him. So when we are seeking help from a decision maker, he knows about the most importance or most favorable system for a particular area. So he will be able to compare this. So we have to compare this using SATI scale. Now, what is the SATI scale? I just, because I want to show you this, I just go to Google and you will be able to find out SATI scale, HP scale, we call it. You will be able to find out very easily. Or maybe I open AHP presentation so that everything will be there. I don't have to give one by one because my computer is also slow. So, okay, I try to find out this where I can show you this presentation. So in AHP, NRT hierarchy process, we use SATI scale. So SATI scale is 1 to 9 scale. What we call is comparing 1 to 9. So when we compare this SATI scale, we compare two pairwise comparison, and a decision maker is asked to compare pairwise decision making. So in that decision making area, now it is opening. So I use this HP scale here. This is the HP scale. I hope you will be able to see it. 1 to 9, normally it is a scale 1 to 9. There are so many scales are available. You just click right HP scale, you will get it. So we can use for comparison 1, 3, 5, 7, 9, and intermediate value also can be used 2, 4, 6, 8. And we can compare the two things. So what we are comparing? We are comparing this. We are comparing investment factor with system and investment factor with vendor. So like that. So we prepare a matrix. So this will become 3 by 3 matrix, and this matrix will be very easily achievable through this, and you can make a comparison. So if you Google it out, you will get so many things on how to use this HP scale. You will be able to do it very nicely. Now I give you some AHP formulas which are also available here. Because this is a human-based decision, so we have to see the consistency. Unless you check the consistency, the decision will not be acceptable. So this is how we see the consistency. For every matrix, there is a lambda value. So maximum lambda value, you can very easily find it out. And based on this lambda value, and this is the size of the matrix, you can calculate consistency index. So once you put consistency index and divide it by random index, this is the random index for given for matrix. If you have 3 by 3, 4 by 4, 5 by 5, our case is 3 by 3. So you divide by 0.58. You get the lambda max value. N is 3 year, 3 minus 1. So you are in a position to calculate CI very easily. So divide CI by RI, you get consistency index, and it should be less than 10%. That's it. So if you are able to maintain consistency index less than 10, your decision is accepted, and you will be able to get the value. How you get the value? That is given over here. You will be able to use this. Use this software is available over here. And using this CGI, you will be able to make the calculation very easily. Of course, you can use formula and find out lambda max value, but this is very easy, handy. So suppose you have matrix 3 by 3, you will be able to use a value which is given by decision maker. If it is 3 by 3, my upper triangular matrix will be having only 3 values. Okay, so this is how I can make. So this comparison is given by decision maker. You can't make it randomly, because if you try to make it randomly, you may not be able to get the required consistency and consistency ratio, because that you have to check it. So this file can be downloaded. You can use this file directly, and you can get the value like this. So here you get 0.6. That means my first parameter. If I see this here, investment factor and system and vendor criteria. So this I get 60%, 29%, and 10%. So this is how I can calculate the weightage of this investment factor, system, and the vendor criteria. Similarly, I can use for this. Now, when there are two, you can simply have 0.5, 0.5, and 0.75, 0.25. Here, there is no need to check consistency because their factors are very less. So, but here you have to check the consistency. So again, go back to this calculator and try to see how you can do it this time. So now it is 5 by 5. You write here 5. So now you see this, my upper triangular matrix is increased. So this is because of number of criteria interactions are more. So this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for 3 by 3 matrix, there are only 3 decisions to make. For 5 by 5 matrix, it is many. Okay. So this is very, very important. You have to make 10 decisions for this. So this is my upper triangular matrix. The reverse triangular matrix can be obtained from this by reciprocating it, or you don't need, because you have automatically this software available. So you have to provide the data. Now, who provides the data? A decision maker. This should not be done randomly, otherwise your weightage will be wrong, and it will not be acceptable by people. So you can find out the weightage of this, weightage of this, weightage of this, weightage of this, and then you can find out the performance of each system based on this criteria, and then you can find out which one will be helpful to get this. And once you finalize this, and if you can multiply, you can provide a synthesized table. And once you provide a synthesizing of the table, you can very easily select which system will be helpful. So you must understand the logic behind consistency ratio checking, and lambda value. So normally this is available. So you can utilize this figure. I am randomly putting, but this is not supposed to be done like this. This is just to save time I am doing, but otherwise you have to compare each criteria. And the normal method of making this table, or what we call as a pairwise comparison, is a very good method is preparing a systematic questionnaire. That if you compare, say for example, I have to make a questionnaire for this, I can compare this in enhancing or in selecting a best RFID system. What is the role of investment factor over system characteristics? to get a potential RFID system, what is the role of system characteristic over vendor criteria? So the decision maker will be able to give you the correct judgment. Now here he will be using 1, 3, 5, 7, 9 or intermediate value 2, 4, 6, 8. So when you put this question, he understands what we want from him. So then he will be able to compare. Now here the chances of judgmental bias is very much there because he's a human being. So he may be biased. So to avoid this biasness, one can go for more decision maker. Instead of single decision maker, we can go for more decision maker, and people can go for say maybe 3, 5. In that case, we use arithmetic mean instead of arithmetic, go for geometric mean. So it will be more acceptable. So we can take geometric mean of his decision. Maybe you take 3. We take a geometric mean of 3 decision and we make a unique decision for this. So like that we can use a different approach here. So single decision maker or group decision making in general. So you will find this group decision making papers available. I have many papers on AHP and GDM and fuzzy, so you can download, and it's very systematically written. You will be able to understand very easily. So I don't think there will be any problem. Only important thing is you must Google out and try to prepare this hierarchy. Now going back to this decision where we have here. If we try to find out the answers, we will be able to get the weightages of each criteria. So this is my first criteria, second criteria, third criteria, fourth criteria, fifth criteria. Normally the total is 1 because it's when we normalize this software already normalize and give you this value. You can very easily understand that criteria 1, criteria 2, criteria 3, criteria 4, criteria 5 has different weightage. And based on that weightage, you can arrange them in priority wise also. So maybe you can compare here, or you can tell that this criteria 2, C2 is more important than this. This is second number C3, C2. This you call it says number 1. This is number 2. This is number 3. This is number 4, and this is number 5. So you will be able to maintain this. So once you get CI divided by RI, if you get less than 10, the table is or the decision accepted. But just now what we did is randomly. This is just to avoid the timing. Otherwise, this is to be done very systematically, because main important thing is this: if you are doing this, you arrive at a correct result. Otherwise, the result may not be correct, and you end up into a wrong decision making. So when you try to do this, you must do properly. Now, when you see here, compare AHP with fuzzy AHP, you use single digit 1, 3, 5, 7, 9, or in between value 2, 4, 6, 8, 9. But in normal fuzzy AHP, you use triangular fuzzy number. So there will be 3 numbers. And instead of 1, you will get 3 numbers. So when you compare them, maybe equal, big, fairly, or something like that, same step you can find it out. That is available. So you can compare 1, 3, 5, 7, 9 with another numbers. So these are my triangular fuzzy numbers, which I am going to use it to compare the pairwise comparison between these two and this two and this two, like this. And we can arrive using extension principle, the weightage of each criteria. So because of the shortage of time, I'm not discussing this fuzzy AHP, but this AHP is very simple. What I have given is more than sufficient to crack any paper. You will be able to do it very easily. So once you know this, how to calculate the weightage, you know how to compare, how to check. If you know this, I think this is more than enough to understand anything. Now you have, the moment you write AHP, you will get all the formulas, whatever is given here. So this random number and some calculation, this is how you can do manually also. If you don't want to use this CGI calculator, no problem. You can do it manually also. These steps are here. So you can very easily use this, and you can solve any problem very easily. There is one more HP calculator, but you can write HP calculator online. You will get another calculator is there. You can very easily see. Now here you will find a systematic calculation of this. If you don't want to select that particularly CGI software, no problem. You can do this very easily using this formula. See here, this is my matrix, and I have another matrix which gives me the weightage of this, and I multiply, and then I try to find out the consistency vector, lambda, Ci, everything you can calculate very easily. So there will be, you will find numerous examples. There will be thousands of paper available on this methodology. So you can see this website. This is a tutorial which is very handy. I recommend this tutorial to many my students to go through and understand what is AHP. So you can do very easily. This is level 1, level 2, level 3. This you can do it very easily. And you can solve many problems. So these are so many things are available. You begin with a simple problem, then slowly increase the hierarchy, and then you can find out the answer very easily. See here, there is a comparison table, because here we did not make any comparison table. Here you can get ready-made table. So when you compare new office with new office, ERP with ERP, Chinese office with Chinese office, this paper which is using AHP to select the priority project in a portfolio. So which project will be more suitable? So I have taken this example very randomly. So ERP implements Chinese office, international product, IT outsourcing. So when you compare this with this, you find one. So this is my 1, 1, 1, 1. And the size of the matrix is 1, 2, 3, 4, 5, 6, 6 by 6 matrix. And these are the things which are given by decision maker. And when you make a reciprocal of this, you get the complete matrix. So you can do manual calculation also. Or if you don't want to do manually, you go to CGI, put this value, and you get the weightage. So as a practice, you can take any one example and go to CGI, put this value, and try to find out this. And it will be very easily solved. So many examples are there, and so many systematic examples are given with weightage. Everything is given over here. So anybody who is interested may go through this Google website and try to find out, and you can very easily find out this. There is another software available which is a decision maker expert choice, but maybe you find a correct. It's a very good decision maker expert choice. So you can see this. Let me show you the images. Yeah. So this is very good software where you give this value given by decision maker. So here you will be able to use sensitivity analysis, and you will be able to change your decision, or see if you increase this by 10%, 5%, what will be the effect on the priority or something like that. So this will be providing you sensitivity analysis. There is a software where you will be able to generate this data and try to select out of this. As I told you that you use Sati scale 1, 3, 4, 5, 7, 9 or intermediate value 2, 4, 6, 8, 9. So you can compare, give this data and try to find out what is the weightage. So this is very handy. It will give you what you call the graphical weightage also, so that you can understand what is it. So this is the software. Same software will be able to give you so many outputs, and you can very easily provide the hierarchy here. You can build up hierarchy. There is a goal, there is a criteria, sub criteria, and the alternatives. So this software is very handy. If you have or you have chance to get this access to expert choice, or you find some crack or something like that, it is worth to take it. It can be utilized for anybody in any decision making, whatever area you are working. So in that second paper, where is my paper? This is the paper. This fellow has used this software, expert choice. So in the expert choice, you will get a this bar chart, and it will indicate the weightages. But just now we have solved with the help of CGI. Okay, so this you can do it very easily using this, and then you carry out sensitivity analysis. So it looks like the sensitivity analysis. So whatever alternatives you are having, that will be given over here, and their weightages. If you try to change them, you will be able to see what will be the effect on priority, final priority. So what I mean to have final priority means, suppose our aim is to find out system X, Y, or Z. Suppose I use this data from expert choice, or from some expert decision maker, data from expert decision maker, and I get that system Y is number 1, system Z is number 2, and system X is number 3. But I have to check whether this priority is correct or not, because it may happen that the priority may change, because this is a judgmental. When you see this, you ask this to one decision maker, it may vary to another decision maker. So this is the one of the problem also with AHP. So many reviewers, they write how you remove inconsistency in this. So this is one of the problem which we can very easily sort out when we are using fuzzy AHP. But of course, when you use GDM, you can still convince the reviewer, and you can publish a very good paper, because if you go to Science Direct, you will find varieties of paper in various area. You will get this. So this is how you can solve very easily, and you can extend your work using this expert choice. Now, if you happen to get the expert choice, you can do this sensitivity analysis very easily, and you can justify your results, and conclusion can be justified very easily. So these are the 3 papers. Sorry, I wanted to discuss. Because of the shortage of time, I cannot explain you fuzzy AHP, but I try to brief this AHP process, whatever time is allotted to me. And if you try these papers, and if you find any problem, contact me. I will able to find it out time to help you, and you can very easily solve this. So you can solve paper, use some method to find out how you can solve this paper. Based on what I have given you the idea about HP, you can solve any paper. And if you dig it out from literature review from Google Scholar, many papers are available which give systematic step by step. Follow one paper and try to learn this method, and you can apply this to your area. So since these papers were related to RFID, so I selected this paper. So there are very less formulas involved in AHP, and those you can solve it by using this CGI software. So there is very little calculation. But as I told you, then when you increase the size of this level, no? When you increase number of criteria here, the number of tables will be more. It will become tedious. But simultaneously, it gives a helpful result also. You'll be able to derive the result very nicely, because this will give you the comprehensive outlook. So this depend upon your problem, how many criteria you select, and I don't think there will be any problem in publishing this. You can apply this in any area. This is in a glass industry. If you have another problem, not RFID, take another problem and use this methodology, and you can publish very easily. So in this time, I could cover this only. There were systematic steps which I could have solved using Excel sheet, but the time does not permit. I hope you will be able to understand this. So I finish this my presentation here. If you have any question pertaining to AHP or this, you can ask me.
May I request participants to please put the queries or want to have conversation with Dr. Qureshi sir? May I ask. There are some comments in the chat box, sir. I'm reading it. The
Oh,
session was
well.
very informative by Amisha Pathak ji.
Oh, thank you. Thank you for that.
Actually, I mentioned one post that the way of presenting the content was very useful and effective because
Okay,
the
thank you.
way with the help of research method and the papers in the recent field focusing on particular research was very new in this FDP. Thank you so much, sir.
Thank you. Thank you. I always try to give one idea or research methodology in
Yeah.
my presentation so that if somebody is really interested, he or she can explore and he or she can become a good researcher in future. So this is a
Yeah, yes, sir. Yes, sir. Yes.
initiative. They say in half an hour I cannot make them expert, but this with this small basic idea they can explore. Researcher work is doing a smart work. Explore, do it, and you become a researcher, PhD.
Mr. Natwar Chogadia and Miss Meeta Chauhan is writing that informative session with nice presentation.
Oh,
And
thank you all
yeah,
of you.
may I ask the participants if you want to have any discussion with Dr. Qureshi sir regarding the content or the proposal if you want to pursue for the research in this field, you may definitely can have conversation with him or you may write email to us. We can have the answers from Dr. Qureshi sir.
Oh, मारी एक website share करो. If anybody is interested,
Yes, yes, please, sir.
they can go to this and they can get me through here. This is my web page, and you get all my information from here. And you can see my area, and you can see some papers. If you want this paper, I can share this paper, no problem. I can give you some idea. If you want to learn any methodology, I can teach you, but you have to try. Don't ask me 100%. You try something and ask me 20%, then it will be nice. Because sparing time will be difficult for me, like that. So, so many different area we have worked together in many fields because now we are working in multidisciplinary. So my focus of area is become very vast. The student comes and he talks about his problem and we solve it. So this is most of the work from my students. Many students they did PhD under me, and many teachers from IIT, NIT, they have worked with me. So something like that. So if you're really interested, connect me. Otherwise, okay, it's part of life.
I would like to mention, yes, Dr. Qureshi sir is a very loyal person. He knows how to handle the students, how to communicate with them.
Yeah, this is what I normally try to motivate. So
Yeah.
if you
In
motivate, you do
Zamana,
good for yourself.
yeah, yeah. You sir contributed a lot in developing my personality also because I
Oh,
know
thank you.
there
Thank
was
you very much.
there was
Thank you
one
very much.
time
Yeah, yeah.
and at that time I was very not like
Yeah, yeah.
today what am I today was not like that but
Yeah, yeah.
but you know how to handle the people, how to handle the research scholars, how to deal with them.
Yeah,
Thank you so much, sir. Thank you.
yeah. Thank you. Thank you very much. Thank you
May I
all of you.
yes, may I request Dr. Nital Nirmal ma'am, Assistant Professor in Production Engineering from Shantilal Shah Engineering College, to present a vote of thanks to Dr. Qureshi sir. Nital ma'am, please.
Hello. Hello. Hello.
Yes, ma'am. Yes,
Hello.
ma'am.
Yes,
हाँ
yes,
हाँ
yes.
बोलो बोलो नीतल मैडम संभड़ाई से बोलो.
Good afternoon to all of you.
Good
I am from
afternoon.
I am from Production Engineering Department, Shantilal Shah Engineering College, Bhavnagar. I'm really appreciate the work carried out by the training coordinator, Dr. Maya Madam, Dr. Vinay Parikh sir, and the entire team of Production Engineering, Mali sir, SN Pandya sir, and CT Gandhinagar. I also thanking them for providing me an opportunity to attend this training program. On behalf of all participants, I would like to thank Dr. M.N. Qureshi sir, my guide teacher when I was in masters, for sharing his research experience with us. Sir, your session contained a lot of information in the field of Industry 4.0 and particularly RFID in the production management. That different kind of the area and the tags like a low, high and ultra high tag, the selection of RFID, the AHP technique, what the topic that you have explained, they all are inciting us in the new era of the learning. Thank you very much, sir, for sharing your valuable time and experience among us. We all having a gratitude to have you here with us in this training program. Thank you again.
Thank you very much.
Thank you
Okay,
so much.
madam.
Yes,
Thank you.
sir.
Thank you.
Yes, sir. Thank you so much for being with us, Qureshi, sir.
Okay, okay.
Yeah.
પરીક્ષ
and,
સાહેબ બોલો તમે.
Sir,
પરીક્ષ સાહેબને જ.
if possible,
સાહેબને.
may I request you to share the PowerPoint presentation, the content with us,
હમણાં
that
આપી
we
દો,
can,
no
yes,
problem.
so that we
No
can
problem.
distribute it to the participants and they may be helpful in the future.
No,
Yes.
no problem.
જી જી
No problem.
પરીક્ષ સાહેબ તમે
But
બોલાવો સર.
ના પરીક્ષ
બહુ
સાહેબનું કહું છું
જબરદસ્ત સેશન હતું, મજા આવી ખરેખર. રિસર્ચ
હવે-
પેપર ફરીથી લખવાનું ઇન્સ્પિરેશન મળી ગયું છે તમારાથી.
ના ના લખો તમે see
હા.
PhD પૂરા કરે post PhD publication is very important for progress of your own career.
Yes, sir.
આજે તમારે પ્રોફેસર થતા થતા થોડા તો કરવા પડશે ને તમારે જે રિક્વાયરમેન્ટ છે 4-5 પબ્લિકેશન. સો ડુ સમથિંગ ગુડ વર્ક એન્ડ ટ્રાય ટુ પબ્લિશ કરશો તો યુ વિલ નોટ પેરિશ. પબ્લિશ ઓર પેરિશ એવું કહેવાય છે ને. સો ટ્રાય ટુ ડુ ઇટ. હા, યુ ટ્રાય ટુ પબ્લિશ. હું તો આ 60-61 ની એજ પર હજી મારા પેપરો ચાલુ છે. એટલે વર્ષમાં 4-5 પેપર તો હું લખું જ છું. Effect factor or scopus. So we tried. But because our system is like that, otherwise they will kick us out. System એવી છે, લખવું જ પડે તમારે. You have to be, if you want to be in system, you publish, do good work. And many things we get, knowledge is ample available on Google, free. Only devote some time, sincerity, hard working, smart work karo, you can do it very easily.
Yes, sir. Yes.
Okay, we leave now.
Yes,
Okay,
sir. Yes, sir.
Thank you very much, all of you. Thank you very much. મજા આવી તમારી જોડે વાત કરતા અને જૂની યાદો બધી તાજા થઈ ગઈ છે.
Yes, sir.
It was very nice.
Yes, thank you so much, sir. Thank you so much.
Okay, all of you, thank you very much. Okay.
Yeah, you may leave now. Yeah. Participants, you also may leave now. We have the next session at 1 p.m. So we'll be sharing link. Have a good time. Thank you.